So once again, we can see we've got a series RLC, because when we open the switch, they're all in series right over here. So I will figure out first whether it's overdamped or underdamped. It's series, and so for series, our damping coefficient alpha is R over 2L. And we're going to look for R. You look at the part of the circuit that you have after the switch is open to get the R. And so our R, that's R2 is 1.2 over 2 times L is 0.1. Yeah, it's the same as the problem before. And so alpha is 6. And then omega naught is actually the same for both series and parallel. It's 1 over the square root of LC. And L is 0.1, and C is also 0.1, so omega naught is 10. So this time we have that alpha is less than omega naught, so we have underdamped. So that means we'll be finding we have a different solution. And so for underdamped, it's underdamped and it's series. And so on this little chart that we have here, series is the left column, parallel is the right column, and underdamped is right here. So let's see what we need for underdamped. We've got VC of 0, VC at infinity, and IC at 0. So we'll need VC at 0, VC at infinity, and IC at 0. We also have this parameter here, omega d, and you can see that down here in the auxiliary relations, omega d. Omega d is the square root of omega naught squared minus alpha squared. So we'll need that. And I didn't. Oh. Okay, so let's start by finding these things over here, and you always start by looking at 0 minus. So at 0 minus, and even though you don't always need both of them, you should always go ahead and find at 0 minus. You might not need both of them directly, but you probably do need them both to find something at 0. So at t equals 0 minus, let's find VC of 0 minus and IL of 0 minus. Even though IL was not one of the things that it said we needed to find, let's go ahead and find it. So this was 12 volts. This was 0.4 ohms. This is 1.2 ohms. This is 0.1 Henry, and this is 0.1 farads. Oh, except this is at 0 minus, and so we don't have a capacitor or an inductor. We have, and we have a short circuit. So we want VC of 0 minus, and do it a little differently than I did last time. Notice it's in parallel with the 1.2 ohm resistor. So I can use voltage division on this part over here. So I can say it's the total voltage times 1.2 over the sum of the resistances, 1.6. So VC of 0 minus equals 9. And while we're here, let's also just go ahead and find IL of 0 minus. And we know that IL of 0 minus, there's no current flowing on this side, so we can say IL of 0 minus is 0.
On which side?
The right-hand side. Because it's open.
Yeah. So, okay. Yeah, that makes sense.
So now at t equals 0, we will have this. We know that this is 0 amps, and this is 9 volts. So this is the same thing we had before, so it's not a new concept. So we know, just like we knew last time, what IC of 0 is going to be. What does IC of 0 have to be?
0.
IC of 0 has to be 0. Okay, and then at infinity, so VC at infinity, what is the voltage going to be at infinity? 0. All right. Now let's find this omega d. So omega d is omega naught squared minus the square root of omega naught squared minus alpha squared. Omega naught was 10, so it's 10 squared minus 6 squared. So 36, so that's 8. So omega d is 8. Okay, so we have IC of 0 is 0, VC at infinity is 0, and VC of 0 is 9.
Oh, because VC of 0 minus and VC of 0 are the same.
They're the same. I just copied that here again. All right, so now let's get D1. D1 is VC at 0 minus VC at infinity, which is 9 minus 0, which is 9. D2, I'm not going to copy the formula, it's right there, so it's 1 over C.
Oh, so IL is 0, IC must be 0. Okay.
Got it?
So is that the same? Would that be the same for parallel? If IL is 0, then IC is 0 as well?
No, because they're in parallel. The current does not have to be the same for them.
Okay. Only for if they're in series.
If they're in series.
Okay.
So 1 over C, so that's 1 over 0.1 times IC of 0. IC of 0 was 0, plus alpha was 6, times VC of 0 was 9, minus VC at infinity was 0. All over omega d was 8. So that's 54 over 8, which is 6.75.
D2 equals 6.75?
Yep.
And then VC D1 equals
9. So then VC of t equals e to the minus 6t, 9 cosine 8t plus 6.75 sine 8t plus VC at infinity was 0. But unfortunately, if we go back and look at the problem, it says determine IL of t, and we just found VC of t. Now, if we look at our circuit is, it's right here. The current through the capacitor is the same as the current through the inductor. So we have VC of t. If we find IC of t, that's also IL of t, because they're in series. So IL of t equals IC of t, and we know that I of t is C dV dt. and c is 0.1. And now we have to use the product rule. So when the computer started misbehaving, derivative we discovered of that e to the negative 6, the voltage across the capacitor, but the problem asked for the current across the inductor. And we said, well, they're all in series, so if we can find the current across the capacitor, then that's the same as the current across the inductor, so IL has to equal IC. So when the computer we know the current across the capacitor is C dV dt, so now we have to find C dV dt. C is 0.1. To take the derivative, we said, well, they're all in series. Function 1, that's F, that's G. The product rule, then that's the same as the current across the inductor, so IL has to equal IC. If you remember, we know the current across the capacitor is C dV dt. So now we have to so the derivative of F is C is minus 6. To take the derivative, 6t. We need to remember the product rule, and then just copy this whole thing over again. Function 1, that's F, cosine G. The product rule plus is F prime G plus FG prime. You and remember then plus from Calc 1, yay, we love to the minus 6t. All right, so the derivative of F G prime is minus of cosine is minus 6 plus chain rule means we've got and then just copy this whole thing so over minus 9 times 9 is minus 72 plus 6.7 sine 8t 8t. And derivative of sine is cosine. F and with the chain rule we've got minus 6 times 6.75 G prime. Derivative of cosine is minus sine plus chain rule means we've got the 8 in there. So it's going to be minus 8 times 9 is minus 72. That's a 72. Cosine. And then 8t. So that derivative will be of sine is cosine. And with the chain rule, we've got then the 8, I can take the 6.75 e to the everybody so has an e to the minus 6t, so I can take that out, e to the minus 6t. I can distribute the minus 6 through this that's a 72 one and get negative 54 and then cosine so that will be 0.1 minus and then I can take the sine 8t e to and then I have minus 72. Everybody has an e to the minus 6t, so I can take that out. 54 cosine 8t. I can distribute the minus 6 and then one nice thing happens and get negative 54 cosine 8t and the 54 cosine 8t negative 54 cosine 8t minus cancel. So that's nice. And then if you distribute the 0.1 and then I add together these two like terms, sine 8t, you get plus 54 negative 11.825. And then one nice thing happens. The 54 cosine 8t and the 54 negative 54 cosine 8t cancel. So that's nice. And then if you distribute the 0.1 and add together these two like terms, you get negative 11.25 e to the negative 6t sine 8t.